Welcome to AI for Good, the leading, action-oriented, global and inclusive United Nations platform on AI. Organized by the International Telecommunication Union, the United Nations Agency for Digital Technologies, in partnership with 40+ UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify innovative applications, build skills and standards, and advance partnerships to solve global challenges. In today's AI for Good event, we are counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished facilitators and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, and welcome back to the Future Leaders in Quantum pre-hackathon webinar series, leading up to the hackathon taking place starting May 16th, 2025. This event is open to everyone and with 4 tracks to participate in, including art, education, innovation, and science. We think there will be enjoyable and informative projects for people of all backgrounds and skill levels. If you're enjoying these workshops and are excited for more hands-on experience, don't forget to head to the AI for Good website or visit www.quantumcoalition.io to pre-register for the hackathon. Today's workshop is for the art track titled Quantum Meets Creativity Using Art and Stories to Teach Quantum. We are honored to have with us Professor Smita Vishweshwara, a researcher at the University of Illinois at Urbana-Champaign. Through her scientific field of expertise in quantum condensed matter physics, she studies the coldest states of matter in the universe, emergent behavior out of equilibrium dynamics, and more. In her research, she forges connections with quantum information science, biophysics, cosmology, and space exploration. Her recognitions include fellowships from the National Science Foundation's American Competitiveness and Innovations Program, the Simons Foundation, and the American Physical Society, or APS. She currently serves on the Global Steering Committee for the United Nations proclaimed 2025 International Year of Quantum Science and Technology, and is the Public Voices Fellow with the Op-Ed Project. She also collaboratively synergizes the sciences and arts and has co-founded the initiative Cascade, the collective for art, science, creativity, and discovery, etc. Her physics and artworks include the theater piece Quantum Voyages, the circus performance Cosmic Tumbles, Quantum Leaps, and the short film Solaria. She recently published a popular physics book with her late black hole physicist father titled Two Revolutions, Einstein's Relativity and Quantum Physics, a dialogue between father and daughter. Professor Vishweshwara, thank you for being here, and the floor is yours.
Thank you so much for having me. It's really such an exciting program that you're all running here in AI for Good. And just the idea behind this coming together of quantum in different disciplines and creating something new and something exciting as part of the hackathon is truly inspiring. And I warmly welcome everybody that is interested in being a part of it. So today, what I would like to do is to give you a little taste of this whole exploration of quantum science and technology through the arts. And really, it's not just quantum science and exploration through the arts per se. When one looks back on the whole history of how quantum science came about, how the quantum revolution came about, it was through bursts upon bursts of tremendous creativity, imagination, innovation, at once joining hands with understanding nature, of inventing something new. And if you look back on the past 100 years, and roughly speaking, 2025, the International Year of the Quantum, celebrates all that's happened since the beginnings in the early 1900s, it's truly vast, truly extraordinary, and it has really changed the face of the earth and society. So, what I would like to do is to take you on a journey where there is this kind of vision that we have, which is in fact all around us, and channel it into the kinds of things we might be doing, bringing together other branches of creativity. From ancient times, if you look back, culture, society, science, engineering, they all, and so many other disciplines, they all came together hand in hand. So, for example, here you see the Egyptian goddess Nut, who represents the sky, the cosmic dome arched across, while the sun god Ra makes his way across through the course of the day. Everything from something like that to Gaudi's Sagrada Familia that you see here, to the gadgets that we hold in our hands. Really, it's coming from such a beautiful confluence of art, science, technology, and innovation. One of my favorites is Leonardo da Vinci's Flying Machine. And you could think of it, if you like, as the coming together of biomechanics, visual arts, engineering, and so much more. Or you could just think of it as humanity's desire to dream, imagine, and take flight. And it is with this sense that I believe that we can approach so much of what we do. So now, coming to quantum physics, quantum science and technology in itself, this is really such a beautiful burst of this kind of confluence. And one of the things to really celebrate, and I believe one of the things that the hackathon can really explore, is just the incredibly diverse places in which quantum science plays a role. Everything from fundamental physics, if you look at nuclear physics, smashing particles together, what is the underlying nature of matter? What are the atoms that compose us? What is inside the atom? How do they come together? And then that to humanity together creating some of the most extraordinary states of matter, condensates, quantum condensates, if you will, or superconductors that can harbor not only the magic of levitation, but fuel so much of what we use today, from parts of circuits to even the basis of current day MRI machines. And then, of course, as is appropriate for the forum here, if you look at telecommunication, it's really changed the way we interact with each other, the way we connect with one another. And on Earth here, of course, the sort of gadgets that one uses there to communicate with one another, like I am with you now, that is just, it really is very much a part of our daily lives. And if you look beyond, if you look to space, there too, what we have set up as humanity, we are constantly communicating with the GPS up there. And then if we look at the next quantum revolution to come, we do have things like quantum entanglement and the like that can happen. So these are just some of the beautiful phenomena that are taking place around us. And it's just when one deeply understands, celebrates, and communicates the richness of what you have around you, that is something really important right now and quite crucial in these times. So that's just a little bit of inspiration for all of you. And one of the things that I do believe is that anytime we create something new, like you all might be here, scientific accuracy is also important. And no matter who you are, whether you're a practitioner of the sciences or just somebody that is interested, one thing that's very important is scientific accuracy. And once you understand one concept deeply at whatever level is comfortable, then already you see the richness, already you see the creativity coming through. And so now, when we turn to what we have in store today, this is really part of the celebration of the International Year of of Quantum Science and Technology. And as Sam mentioned, I'm on its steering committee, along with, in fact, Gillian Makamara, who's part of ITU. And it's through this communication, this happy, happy communication, that I'm here today sharing this with you at AI for Good. So when we come to the track in the Quantum Hackathon at hand, it's the art track. And if you look at what it describes, I just loved the description. Express quantum ideas through music, visual design, or storytelling. Science and creativity really do go hand in hand. Art, science, creativity, imagination, rigor, analysis, these are all really part of, in a sense, the same realm, the same world, if you will. And so now the question comes as to how you might demystify, how you might explore quantum mechanics through the arts. And this is what I'd like to share with you. I would like to share with you what we do in practice and offer you inspiration and perhaps some kind of vision of the kinds of things anyone might be able to do. So, and Sam, is there anything that we should discuss before I actually get into the kinds of things I'd like to share today?
I think one early question is related to the different types of qubits and architectures that are currently used in quantum computing. Quantum computing is very unique in that it incorporates a variety of different types of qubits, each with their own design and different constraints, limitations. How do you see the interplay of art and science reflected in the development and innovation of early quantum computing systems?
And I'm glad you're asking me this because for today's topic, it's a subject that I study in my research practice. It's not a topic that I will go into deeply. And so I think it's a wonderful question, and I may as well share a few things with you right there. So if you look at where some of this, let me say straight away, what distinguishes quantum physics from classical, quantum mechanics from classical mechanics? First off, quantum is, in a sense, you could say counterintuitive, but one of the things that we have going, it's a movement for many of us practitioners and educators, is really, as was written, to demystify this. And one of the most unusual things that the quantum world holds is the possibility of superposition. So superposition is just the fact that something can be in two different states at once. So it could be a little magnet pointing up and down at once. It could be any other kind of qubit photons of different polarization. There's a whole spectrum of possible qubits that you have. Now, if you step back a little bit, first off, before art, there's philosophy. What does it mean to be? And so this goes back to the whole notion of quantum interpretation. And if you look at the interpretations that there are the multiverse, for example, or the Copenhagen interpretation, where the act of observing determines reality. All these are really conducive to art. So we've seen so many different movies where there's the multiverse. Ant-Man, for example, going into this whole, there's a beautiful superposition scene. It's something that we do a lot, quantum superposition. And then there's entanglement as well. So superposition and entanglement of two different bodies that are correlated in quantum ways. And when taken apart, the measurement of one determines the outcome of the other. If you look at these two things, they're really mind-blowing. And so if one is able to represent this through art, that itself, that is a fine topic. It's beautiful. In the next of the series that we have with me in it, since Sam asked this question, I'll talk a little bit more about how we depicted, in particular, the multiverse scenario. But in general, what's amazing is that these two concepts coming together on the grand arena of a quantum computer, how do the spins talk to one another? What is the dynamics? How does one influence the other? And a lot of times, when art is able to represent that either visually or through sound, then not only the public, but oftentimes the practitioners themselves gain a deeper understanding of what the whole process is, and also what the next steps could be, what the next innovation could be. So that's just a little taste. And Sam, thank you for asking me that question. Please do keep it in mind, because that's not a topic I will talk about a lot for the rest of what I'll share here. So what I will share here is I'm just going to tell you a little bit about the kinds of things that we've been doing, my collaborators and I. Quantum Voyages is a theater piece that we premiered in 2018. I'll talk more about it in the next of the series. And it's actually going up at our Krannert Center for Performing Arts on April 19th. So we're really gearing up for it, and it's in my bones right now. And I will be sharing this with you in the second half of my workshop. There's an interdisciplinary course called Where the Arts Meets Physics. It's project-based. And I hope that some of what I share with you in the coming several 20 minutes or so will give you little seeds of inspiration of how, whether you're a quantum physics major, if you're a student, or somebody who has no technical background but is really curious about science, how they can come together and create something completely new. And I should say that the students have just been absolutely magnificent in letting their imagination just take flight, and then going through that whole process of taking up a project from conception all the way to the realization. And I will give you a few examples of that. Quantum Rhapsodies is a multimedia piece. And if time allows, I'll show you a little video clip from it. And as Sam mentioned, Solaria is a short film that you can find online. And I will give you links to that. And so that's not based on quantum physics, but it is a science-based fantasy film of the spirit of the solar system encountering humanity. So these are just some examples. And this is the United Nations proclaimed International Year of Quantum Science and Technology. And one thing to watch out for is that it's a fantastic, in a sense, grassroots effort. So there's every events, big and small, and this is part of the celebration that we have here, this big event that you have here. And one thing to watch out for is, what are the kinds of things that are going on? You can look on their calendar, and undoubtedly there'll be lots to inspire. So this is just a taste, and what I'll do is, through the remaining time I have, as far as possible, I will give you a little taste of some of what we create. So how did I end up doing this? How did I, in my daily practice, really end up bringing together science and the arts collaboratively. So, in a sense, for nearly 15 years, and actually by now it's a quarter century, for nearly 15 years, I was dedicating myself to research in what's called quantum condensed matter physics. And condensed matter physics is just the physics of the way individuals behave when they come together as a collective whole. Almost sounds like a societal thing, and really, even though humans are too complex for us, we do study societies of quantum particles, if you will. And it has been super exciting, that study. My mother is a quantum chemist, biophysicist. My father was a black hole physicist, so it really was in my it's in my blood, the science. But the arts too has always been in my blood. My grandfather was a playwright. We were steeped in music when growing up, my sister and me. And throughout my life, some kind of artistic practice has always been important. So, and so this you can see, this is my school in India, where we'd be doing theater and music under a banyan tree, a stage under a banyan tree, capoeira, choir, writing. Writing was always something that was part of me, along with doing calculations. To this day, I always carry a little book when we travel and take down little notes, and there are stories in my head that are just bursting to come out. And so, what really happened in the course of maybe the last 10 years as a practicing faculty member, there was a moment where sort of I decided, and I'll tell you what it is, to embrace the arts into my daily life. And I really was able to bring it into my career in the ways that I shared with you already. And one of the things to say is that these two, as we already talked about, are just really naturally combined. If you look at Einstein, for example, the most beautiful thing we can experience is the mysterious. And it's really, really, really inspiring. In some way, we're all drawn to the mysterious, and contemplating that, in a sense, not only brings you to the core of who you are, but it also just opens up something deep within that connects you to nature, connects you to the universe, connects you to each other. And as he says, art and sciences are branches of the same tree. And we do art when we communicate through forms whose connections are not accessible to the conscious mind, yet we intuitively recognize them as something meaningful. And so, one of the things I encourage my students is, when you're bringing together science and the arts, it's not just making something pretty or artsy or the like. The moment you try to understand it deeply, the moment you try to do something creative with it, already it's art. And it's the other way around too. When we work with artists, it's not, oh, we'll just take a scientific theme because it's cool or trendy or something. No, there's a deep confluence, and what comes out is something really extraordinary. And neither one could have created this without the other. So for me, this was actually one of the biggest influences was my father, who not only was a black hole physicist, he was a planetarium director. He would write books, and a big part of my, big change in my life came about when he and I began writing a popular physics book together. Him, Einstein's relativity, me, quantum physics. We wrote this as father and daughter. Started off as letters. He passed 8 years ago, and I was able to finish this book and bring it to completion, actually just last month. So a lot of the research that I did for the book really drove both the artistic expression and also a deeper understanding of quantum physics. So let me actually give a sweeping overview of some of the concepts in quantum physics so that we're prepared for what are the concepts that we might want to share? And already Sam asked a wonderful question on quantum computing and qubits and the like. So there's that already. And let me also walk you in an artistic way through the history of quantum physics and some of the key phenomena, and then we can get into some examples. So before then, is there anything else I should share at this moment, Sam, before we go on a sweeping journey of some of the dazzling concepts that evolved in quantum science in the last 100 years?
Yeah, I mean it's been very interesting so far. I think one brief question is, how do you avoid the trap of art becoming kind of decorative for science rather than a meaningful dialogue partner?
Yes, and this is super important. And this is why that's what I meant by not making, not using art to make your science pretty, but just, or, pretty pictures or whatever it is. But, and what Sam pointed out was really something much, much, much deeper. And we avoid it by having a completely different practice. So when we work in a sense, who becomes an artist, who becomes a scientist? For example, you'd mentioned this community cascade, and we work so there. It's co-founded by Latrell Bright, who's a theater maker, and Stephen Taylor, who's a musician. So when the community that we built, who is an artist, who is a scientist, we absolutely respect expertise. The fact that somebody's been working on this physics for 20 years or compositional music theory for 20 years or theater making for 20 years. The specialization is and rigor is absolutely important. But then beyond that, through deep listening and communicating together and saying, where are you coming from? What is it that draws you? Asking each other that, the act of deep listening and creating together. So it's really that sort of outlook that we practice, and that gives rise to the sort of the sort of things that you see out there, not just by us, but by so many of the practitioners that I've met in the science art realm. This is always the common feature: coming together, dialogue, asking what are the most profound concepts that are calling out to you, and creating together. So now let us just a very, very quick view of quantum physics, and I'll put the artistic in it already so that you'll already see it weaving through. And then as time permits, I will just share some of the examples that I mentioned right at the beginning. It all began in the early 1900s when, until then, light was accepted as a wave. And of course, we use the wave property all the time. I'm communicating to you. There's radio waves. We really are using all these features of interference, modulation, and all that. And so, yes, it is indeed established that light is a wave. But then the seeds of quantum were planted by asking about the nature of glowing beings, metals when heated, the stars that are blazing in the sky. You and I are also absolutely glowing beings, as you can see in an infrared camera. And what's beautiful and amazing is that we radiate in the same pattern, black body radiation, that depends only on one parameter, and it's our intrinsic temperature. So now, in trying to understand this pattern of radiation, it wasn't enough to describe light as a wave. And this is when Planck came up with his notion that light is emitted in little packets, in bundles, in quanta, and that is how quantum was born. And then after that, so what is light? And so you can ask yourselves that. It could mean different things to you. And just trying to understand light, I talked about these two different properties. There's polarization, just celebrating light and asking what it is and trying to express already, I think, gives you a beautiful path for creating something new. And so now, for example, in Quantum Voyages, which is the adventure tale of two voyagers guided by the spirit of wisdom going through different worlds. And the first one, as with the story, and as with many a story, begins with light. And so they encounter this quantum ensemble here. And then they also encounter what we call a quantum sage. These are real life physicists that we bring onto stage. Gina Lorenz, for example, she created the public quantum network. She's my colleague. Just beautiful in the way she thinks about light, in the way she shares with public. And when we asked her to come onto stage as a sage and share some of her wisdom, she showed us a little piece of paper and she said, I tried something out and we looked at it. It was a poem written in iambic pentameter. And so we said, wow, this is amazing. And so she will be performing next week, in fact, and she also performed in Anaheim. We performed all of Quantum Voyages also at the Global Physics Summit. So it's really the process of creating all this has in it. And as Sam asked, how do you bring together science and the arts? And Latrell Bright, our theater maker, she's the director of this. It really comes through coming together in a room and exploring these concepts. So in our version, Sapienza, the spirit of wisdom, comes and shares what light is. And so this was something that Latrell and I scripted. And so this is what she says. And she says it, this particular version, in a very jazzy way. We have music coming in, and Sapienza is telling you light, the alluring, elusive. Sometimes a wave, sometimes corpuscular bundles of energy. Sometimes here or there, sometimes here and there. The glue holding matter together. Light, the quintessential quantum. Quantum, it is the ancient world where curiosity leads to uncertainty. Light, the constant voyager, the messenger, peripatetic, bouncing, tunneling through, unstoppable, except in death, and so on and so forth. So this is just an example. Play with it and beautiful things will come out. And not only just poetry and the like, but play with light, use polarizers, and you never know what kind of magic you may be able to create. So that's the story of light. And so then through the history of quantum physics, what happened was that once light was looked upon as both a wave and a particle, and for example, Einstein's proposing the photoelectric effect established what would then become the photon. This Monsieur de Broglie, a French duke and a prince, who was more interested in physics than his duties with, war and the like, and he switched completely to physics. He asked this really weird question. If light can act as a particle and a wave, why not matter? Why not you and me? And that was absolutely crazy. You and me, we know we kind of act as particles, but as waves, But if you look at it, the microscopic world is made. If you look at electrons, you see electrons acting as waves. That's the basis of the way atoms behave. So these are the electronic orbitals. And look at how absolutely gorgeous they are. And so if you look at the way electrons wrap themselves around the nucleus, you have all these shapes where electrons are behaving as waves. So you have this electron cloud wrapping itself in different forms around its parent nucleus. And then if you have, and so that was very different from, Rutherford did have this key observation that the nucleus is all at the center and the electrons wrap around, but they're not going around like planets around the sun. they're going around in these beautiful, they're not even going around, they're sort of spread out in this beautiful diaphanous pattern. And then if you have many of these together, what do they form? How does matter behave? And how does it make you and me? How does it make matter? How does it make metals, insulators, semiconductors? And for that, one needs to understand quantum many-body physics and the way we come together. And intrinsically, we are two breeds of particles: fermions, unfriendly particles, electrons are fermions, which will never be in the same quantum state, and bosons, photons, for example, that would prefer to be in the same quantum state and live in a harmonious ground state if possible and form things like superconductors and the like. And so one of the things we had a lot of fun doing was to say, how can we portray, for example, electrons inside metals, where together they form what's called a Fermi sea, named after Enrico Fermi. And he studied these quantum particles and their fermionic nature. And so we depict that through theater, we depict that through art. This, for example, was from the course that I mentioned. Danielle Markovich, she was a physicist and a painter, and you can see she's depicted not only what it looks like inside a crystal lattice, but also how do electrons move through it. And once in a while it's a raging, tumultuous sea in there, can they achieve states of harmony? And that's really the secret of superconductivity, where you have this beautiful state of matter where electrons can flow free of resistance. So I'll tell you more about it in the second part of the series. But if you look at the secrets of superconductivity, I can tell you that it's buried somewhere in this painting made by Danielle. So that's giving you a taste of some of the physics topics at hand and a sweeping evolution of some of quantum behavior through maybe the first 50 years. But of course, there's many other topics, nuclear physics and something that rules our world and politics in a pretty strong way. How did that come about? This is something where history and quantum physics went deeply hand in hand. And now, when we're looking at, let's say, the second quantum revolution, when you have quantum computing, information science, and technology, this is, of course, a huge, huge development that has happened over the past decades, I will say, with promises of a lot of excitement to come. So this is a sort of sweeping view of some of the quantum concepts. And as I mentioned, in all our projects, understanding the underlying science, technology, and engineering as appropriate, and bringing that into the synergy with the arts and culture is always very important. And I do think that more so in this day and age, scientific accuracy is very important and something that should be emphasized, as I think should the wonder, the awe, and the sort of public, reaching out to the public. So this is giving you a taste of the coming together of the arts and science, and a taste of quantum behavior, some phenomena. And in the last 10 or 15 minutes that I have left, I'll walk you through some of our practices and some of what we do. But I think, Sam, maybe now is a good time for me to pause in case you have any questions.
I guess one question, just brief, since I know you're running out of time, but a brief question would be, have you encountered any examples where artistic interpretation actually led to a new insight in your quantum research or other studies you've looked at?
Yes, yes, absolutely. And this is one thing that I emphasize too, because when you're out there and you're in this exploratory mode and there's deep listening going on, as a scientist too, you ask new questions. And so one thing I'll say is I talked a little bit about quantum interpretations. When we had to really explore that in our work, we realized, so one of my mentors, Tony Leggett, who's a Nobel laureate and a knight, knighted by the Queen. And he's my just our sort of fountainhead of wisdom that we have here. He has thought very deeply about the interpretations of quantum physics. And um, these discussions became much more important to me. And now, when we're looking at the quantum revolution, the second one, so to speak, where all these qubits and their entanglement becomes key, then you really also have to talk about interpretation and understand it. And so Gina Lorenz, the quantum sage who I mentioned, my colleague, she and I have become much more interested. And it was really through doing quantum voyages, seeing what Tony had to say, and trying to understand deeper. Quantum many-body phenomena is also something that's, part of my study. And there was a time where my theater collaborator, Latrell Bright, had us in the room and move around physically. And that physical movement showed me so much more about what's possible and the kinds of interactions that can be going on, be it inside a solid or at the galactic level. And so these are two instances, for example, that really showed how the arts can bring out something absolutely new. Another, maybe in the next half, I'll say a little bit more about music. And there were quantum algorithms that were made into music. And I can say a word about that next time. So, and Sam, how much time would you say I have left? Because we may want to leave a little time for questions from you. I don't have to cover all the examples that I have.
I don't have any more questions right now, but I think you have 10 to 15 more minutes left.
Okay, perfect. Okay. Okay. So, in Where the Arts Meets Physics, this is project based. And so, what we do is we really bring together uh, students from all different majors. There's a lot of students who are physics majors, and they also tend to have an artistic side. Uh, of course, we also have people from different artistic backgrounds, so theater, music, also design, visual arts, writing, all of it. And it's developed into something quite beautiful and extraordinary thanks to the students and the really creative teaching assistants that I get to work with. And so, just as an example, for example, this is our Cranert Art Museum, and this is an install exhibit that we had. This was in 2018. We've had a culminating event ever since. I've taught it for maybe it's been about, yeah, I've taught it since 2017. And so, just to give you an example, Callie Roy here is an astrophysicist and also somebody who did pottery from a very young age. And so, just as an example, I will show you what her project turned out to be, and that will give you a taste of the kinds of ways in which we do our explorations. So the first is, and of course, this is over a semester, but I think the same principles can be applied for even a focused kind of working group in a week, let's say. So the first is really to immerse yourself in different scientific themes and artistic. So for example, this is a little more broader than quantum physics, only it is still physics based, but black hole mergers. That's something that's very much dear to my heart. And the giving off of gravitational waves, superconductivity, dance, music. And the way we immerse ourselves, we do bring experts, artists who will guide us through little bits of theater or have us, they'll teach us dance moves and they'll say, that's your vocabulary. What will you do with it to depict and embody scientific concepts? So first, exposure, and then exploration. And a lot of it is just free exploration. That's part of it. Sometimes you don't have to have the end goal in sight. It's the exploration and putting your heart into it that brings something new. If you already have a goal, oftentimes you won't find something new. And so, I mean, you have to have a broad goal, I suppose, but exploration is key. And so, for example, be it Caliroy exploring different ways of using her pottery expertise, or studying the nature of gravitational waves, both of which she did. And then finally, there's expression and execution where we come up with the product or the project. And so, for example, this here on the right is Caliroy's pottery piece of two black holes spiraling into one another and then giving off these gravitational waves. In a later, and this was the first time that gravitational waves were detected and reported in 2016. And it was tremendous. It was sort of a scientific breakthrough. And so you can see that we were all extremely interested in the class, all of us in the class, studying the evolution. And so you can see here how Caliroy came up with this. And it was amazing because our exhibit was next to a ceramic exhibit that had works from, 2000 BC or what, or just really, really ancient. So it was so beautiful to have Caliroy's work next to this ancient ceramic and a lot of other work as well, which what the students made was truly extraordinary, and not just single person projects, but also collaboratively. On the left, you'll see in a later year, which is Jiankang, she used a form of Japanese woodcut and she learned it from the beginning. And what's extraordinary here is not only the finesse of the woodcut to depict the same thing, but the number of colors that she uses. It's print after print. And really, the mastery that she shows here is extraordinary. And then, of course, you have Van Gogh and others who were also inspired by this kind of thing. And you can see in the modern day world how science and scientific themes might carry this kind of artwork to a new dimension. So this is one example. Okay. This is I'll just put this here. So this was in the style of you've probably seen pictures of Marilyn Monroe and the like in this kind of Andy Warhol style. And one of the students said that he wanted to do something like this with physicists. And I said, you can't just use a program and just do this and say, this is your final product. You need to learn what they said. And so here you really have some of the debates on the nature of reality that, Bohr and Heisenberg had the Copenhagen interpretation where observation determined reality. Einstein and Schrödinger hated that interpretation. And so now you can see the debate that goes on. And once you put that in this very attractive style, and I was amazed with how the audience, they just flock towards this. What's going on here? Why? Who is this? Dracula? No, it's not Dracula. It's Niels Bohr, or no, sorry, Heisenberg. The one with the red eyes is Heisenberg. And so then it drew them in, and then they actually read what was written there. And so that's, that was something quite beautiful. So that's our class. I don't have time to go much into the other pieces. Quantum Rhapsodies was a multimedia piece that involved scripting and music with this beautiful Jupiter String Quartet, my friends and colleagues in the music department. This was really a contemplation on um, the quantum, a reflection on quantum and the ways it has, the ways in which nature manifests the quantum world and the way it comes into our lives. So it's really a poetic exploration through narration, music, and visuals. And the visuals we developed once we had the script and the music. We developed the visuals in at the Beckman Institute, also with my course. And so some of what I told you, the birth of quantum physics, and then all the way through Louis de Broglie's what if, what if? And so on the right here, you'll see Alice in Quantum Land. And we had a lot of fun putting this together. And we had some really sportive scientist families and their children who are ready to be Alice and the Mad Hatter and the like. So while I don't have time, maybe I can, yes, I can actually point you to some links where you will see scenes of this. And so it was really playing on this whole notion. I already told you about de Broglie. So after long reflection and solitude, which by the way is important, a French duke once mused, if light grappled between being a wave and a particle, why not matter too? By golly, you and me, and cricket balls or tennis balls or whatever it is that people like to play wherever you are, acting as waves? Hardly. Imagine such a world. And yet, shrink down smaller and smaller. Alice, on a quadruple dose of the drink me potion, can go through two doors at once, the way waves can go through two slits at once. Yes, the minuscule quantum world of electrons, protons, and atoms is nothing like what we see around us, and yet we are made of it. And so then the thing that I don't have time for, but I can send you a link. We did a little clip of this imaginary Alice going into this quantum world and seeing how strange it is down there. So we premiered this at our Beckman Institute, and we do have plans to take it on the road, in fact, in October. So you can see here the visuals, the quartet, and this is Latrell Bright doing the narration. So this is just one example of the kinds of things that are possible. Oh yes, and people keep asking us, was that really in any way inspired by Bohemian Rhapsody? And we say, well, I love Queen. I say, if you look at this, it starts off, is this the real life? Is this just fantasy? Caught in a landslide, no escape from reality. And actually, quantum is really the study of reality and the strange things that happen and the landslides that you encounter. So, drawing to a close, and these are links. There's an art science festival that we had virtually during the pandemic. You can find both this film that Sam mentioned right at the beginning and also clips from Quantum Rhapsodies. We've really had quite an enchanting time. And I should say it's infectious. There are so many practitioners who bring together science and the arts. And when you put us in a room together, it's just so amazing. We just don't want to stop. We create more and more, and things come out on the large scale. So in Anaheim, we had the American Physical Society had the largest gathering of physicists of 15,000 people last month, and this was a special for it called Quantum Fest. We also had circus collaborators, Le Petit Cirque, and they collaborated and really took all this literally to new heights. So let me just, hopefully it's giving what I shared with you has given a sweeping view of what's possible and how you can take inspiration from everything, what you might share with a friend, all the way to the profound phenomena the profound cosmic tumbles and quantum leaps that are going on in the dance of the universe. And so, with that, I thank you for joining in this whole adventure, and I look forward to seeing the kinds of things that come out of the hackathon. Thank you.
Thank you very much for that great talk. If it's all right, I have one final question that I think would be interesting to our virtual audience. Do you have any advice for hackathon participants who are thinking about applying their skills in quantum technology across other fields, be it art or uh, other experiences you've had?
Yes, yes, absolutely. And as you mentioned in your previous question, it depends on which way you want to go. So the question is, do you want to bring the quantum science and technology into the art, or the other way around? Or like we do you just want this to be a common practice where something, you just go on the adventure and something new comes about? So let me say that, for example, if we were just to take, let's say, things like quantum algorithms, we actually have a collaborator who created something called a spin doctor. It's like a theremin. Now, you don't have to do that kind of thing. But one of the things you could conceive of doing is to say, how do we depict these algorithms? You have things like Shor's algorithm and the like, but maybe you're doing something new. Maybe you're doing something new in your practice, in if you're working with, say, quantum computers or the like, just by asking, how do I visualize it? Or how do I understand better what's going on? And this is where you do need art, be it description, be it math, to be honest. Math itself is so beautiful in the way it fundamentally um, encodes and expresses things. It could be music. So just trying something like that a little bit. Or it could be the other way around. You're an artist and you love this quantum, you love the spooky action at a distance. And I would say just seek out an expert. And one of the things that I found that was quite amazing is people don't say no. I mean, there's a lot of people don't say yes either, but if they're not saying no, well, oftentimes they do say yes. When you're enthusiastic and you go there and you say, I want to learn this a little deeper. And if you're an artist, ask an expert. Whatever your practice is, you say, this is what I do, the visual arts, or you script, or whatever it is. Go to an expert, ask them, say you want to create something new where you join hands, and something extraordinary will come about. And so that's just some of what we found in our experience, and just sharing a little bit of what you can actually do in a practical way.
Awesome. Well, thank you again for your informative talk, Dr. Vishweshwara. What an exciting prologue to this quantum adventure that is QC Flick. To our audience, we look forward to seeing you again soon with our next Reflick workshop called Playing with Possibilities, Teaching Quantum Through Chess. Don't forget to check for more updates on our website, www.quantumcoalition.io, and pre-register for the Flick Hackathon taking place this May. Thank you for listening and have a great day.
Thank you for participating in today's AI for Good session. We hope you've learnt something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for good.